Hi everyone, welcome back to the classes for quantitative aptitude. And I think in last class we have discussed ratio and proportion, right? So for 5 minutes, let's recall what we have done in the last class. We have seen the concepts of ratio and proportion. We started with the ratio, wherein we just discussed what is ratio. Moving forward, we also discussed how to calculate ratio of how to calculate from ratio to percent and percent to ratio. If I'm not wrong, we must have gone through some of the properties, like if we multiply with the same number and divide by the same number, same constant, then it does not affect the ratio. Also, if we divide the same constant in numerator and denominator and right, then also it does not affect the ratio, right? Moving forward, we also have must have discussed that if in case the property is a by b is equals to c by d equals to e by f equals to something something equals to k, then value of k becomes the addition of a plus c plus e plus f, all the numerator upon denominator. Correct? Also, we must have understood one of the property that in case if a upon b is greater than 1 and k is some positive number, in that case a plus k upon b plus k is what? Is less than or greater than? Can anyone out to tell me? Will always be less than a by b if this is greater than. But if a by b is greater than a by b uh, is less than 1 and k is some positive number, in that case a plus k upon b plus k will be greater than a by b. So you have to remember these things, right? So let me go back to the previous things what we have discussed so that we can recall easily. So yeah, we were discussing what is ratio, why we need it, why calculation for percentage, right? Ratio from percentage, then properties we have done, then we have done the division property, ratio of two fractions. So I told you one star mark here that ratio of fractions is not always an integral ratio. Remember root 3 by concept. So a by b, we discuss what is duplicate versus triplicate, what is subduplicate, what is subtriplicate. Sometimes uh here I am just remembering one thing. Sometimes there was one question that this says a cube minus b cube upon a plus b something and something. Find the mean proportion, right? So actually, so once you don't know what is mean proportion, this question is invalid for you, right? You cannot attempt also. You cannot take this question, right? You have to understand that a cube minus b cube is the other thing, but you have to understand what is the mean proportion. If you don't know what is the mean proportion, do you think you will be able to solve this question? No, right? So we have to understand the things. That's why I always says that we must focus on the concept ones. Once they are done, then we have enough time, or we can take a 1 day of time to go through all the tricks, all the available material which we have, right, to optimize the things. But once your foundation, the concepts are strong, then only you will able to solve the questions. That's why I always try to give you a theory first. In 1 or 2 lectures we just deliver the theory so that you are done with the foundation. Then after that we can have any amount, like any type of questions coming up with that, we can able to solve it, right? Okay, so let's not waste much time over here. Let me just go forward. So this is what I was asking. Then we have also discussed this inequality. So this was for the equality. If we have a by b equal to c by d equal to e by f equal to g by h, in that case I told you that this is a normal question or a normal analogy where we get this kind of relation. Then we also discussed if they are unequal, then the range lies between the lowest and the highest of the ratio, right? And then I talked about one of the important results which we derive here is nothing but if a by b is greater than 1, then always remember that a plus k upon b plus k will always be less than a by b, wherein a minus k b minus k will always be greater than a by b. See, these are the things which you have to remember anyhow. I cannot help in that, right? So how you going to remember that? You don't have to mug up, you simply have to solve as number of questions. Once you that a habit comes in, right, you will be good enough, right? Okay, so now I think this is pretty much very basics which we have done. Let's start with some of the concepts, right? So first concept is bridge concept. Please pay attention here. Bridge concepts. Now what is bridge concept? It is nothing but sometimes what they will give A is to B and B is to C, and will ask you A is to B is to C. The simple analogy of question, if I want to shoot up here, it's like if the salary of A is to B is in the ratio of 4 is to 1, and salary of B is to C in the ratio of, let's say, 3 is to 2, and total the sum of total all the salary is something 5730, find the salary of C, something like that, right? Or if they have given ratio of 2, find the ratio of ABC. So from this I can find A is to C also, I can find B is to C already given, right? So these are questions which are based on the bridge concept, right? First let's understand what is the what is the basics of these concept. This to take the LCM, right? The basic is to take the LCM. For example, let's say I have 4 is to 1 and I have 3 is to 2. Let's say I have A is to B in a form of 4 is to 1 and B is to C in the form of 3 is to 2. Now what the concept actually says, it says you make B as a common platform, or you make B as a common bridge, right? So if I multiply this by 3, because this is nothing but 4 by 1, right? If I multiply this by 3, I will see that B will become common to this. So what is this? 12 by 3, right? Or I can simply multiply by 3 here. So this becomes 12 is to 3 and 3 is to 2. So 3 3s are common. Therefore, A is to B is to C is 12 is to 3 is to 2. This is nothing but we have just taken the LCM. If you see what we have done, we have taken the LCM and we have provided the common to the B, right? Now that is okay, that's a concept, right? But for example, what happens is they will tell you some of the places I have seen, they'll just tell you the the basic tricks which works for ABC. But what happens if I have A is to B, I have B is to C, I have C is to D, I have D is to E, I have E is to F. Now can you apply those tricks which are been told there, right? Or you try with the LCM, so that if you try with the LCM you will get the answer for sure, but it will take time, right? Neither we don't want that much of time to be wasted on this, right? So what is bridge concept, right? So let's come to the bridge concept back. So I think introduction is clear to you, right? So bridge concepts is nothing but, for example, if you have A is to B and B is to C, let's say I give here 4 is to 1, I give 3 is to 2 here, and I need to find A is to B is to C, correct? Then what you do, you write A is to B and you write B is to C, you copy this here, you copy this here, and you multiply, and the whatever ratio you get is the answer of this ratio. What I mean is, that is 4 is to 1, 3 is to 2, you copy 1 here, you copy 3 here, 3 4s are 12, 3 1s are 3, 2 1s is 2. So this is the final ratio. If you want to simplify, you can simplify. But if you see, is this matching? Is this matching with this? Are you understanding it? This is what we have is called as bridge concept. But again, the question is not like this. If question is something like this, A is to B is to C, C is to D, D is to E. But you have mug up this, what is called as this trick, right? But you know only this trick, right? So that's why I'm saying concept is the key. Otherwise, after that we'll see. So if you have in case of A is to B, okay, B is to C, C is to D, and D is to C. I'll give this for this, and then again you can create your own this. So I need to find A is to B is to C is to D is to E. Okay. So what we do is, what I'll write as, I'm just to explain, I'm doing that. You know that a is to b is nothing but a upon b, and it is b upon c upon d, and d upon e. Let's say this is numerator 1, this is denominator 1, numerator 2, denominator 2, similar for numerator 3, denominator 3, and numerator 4, denominator 4. Alright, so what you are going to do is, if you need to find a is to b is to 3, first a will come from multiplying all the numerator n1, n2, n3, n4 is 2. Then you have to decrease this with the denominator. So d1 multiplied by n2, n3, n4. Then this is d1. Then again you will take to two values, that is d1 into d2 into n3 into n4. Then the third one will be d1, d2, d3, d4. Then the last one you will have d1, d2, d3, d4. So I think this makes more clear to you that you have to start with all n and you have to end with all n, and in subsequent in between you have to just change the sorry, by mistake it happened. So in subsequent you have to change the values of the denominator places, correct? Your first you will start with the first, then first 2, then first 3, and then last all 4. Are you understanding it? Let's take one question here. Let's say a is to b is 4 is to 1, b is to c is 2 is to 3, c is to d is 1 is to 2, d is to e is, let's say, 2 is to 4, let's say. Okay, so I need to find a is to b is to c is to d is to e. So I remember that a is to b is to c is to, I remember that we'll start with all numerator multiplication, that is 4 is to 2 is to 1 is to 2. Then I'll take the second or d1 and multiply by all the numerator, right? 1 is to 3 is to 2 is to 4. Then I'll start with the 1 into 3 into 2 into 4. Then I'll start with the denominator 3. So 1 into 3 into 2 into 2. Somewhere we have done wrong here. So it's right. 4, 2, 1, 2. 4, 2, 1, 2. All numerator n1, n2. For your sake, I'm writing it here. Then d1. So this was d1 multiply by, sorry, yes, here we gone wrong. Sorry. So it will be 1 into 2 into 1 into 2. Then, so this is d1, n2, n3, n4. So here it will be d1, d2, 1 into 3 into 1 into 4. That is 3 and n4. And here it will be d1, d2, d3, n4. That is 1 into 3 into 2 into 2. And what is the last one? Can anyone tell me? 1 into 3 into 2 into 4. Are you getting it? Will you be able to solve this? So this will be the answer. So this is what we have a bridge concept. So for 2, generally you will find questions for 2, or the question in which you have to use the bridge concept will include a is to b and b is to c. So for that you know the trick that you write a is to b here, b is to c here, copy this, multiply it, you will get the ratio. Are you understanding it? Correct? Makes sense now? Okay. Now before we jump into the new concept, let me write the last concept of the ratio, that is comparison. Okay, when we do comparison, okay, what is comparison? Where we need to find out which ratio is greater or lesser, right? Sometimes you will see those type of questions here, right? Which ratio is greater or which ratio is lesser, right? To find out, there are various concepts you will see in the market. They are flourished with many concepts, right? They will write see the margin, do something that. So whatever sort of possible combinations we have, I will try to give you here. Okay. Now, for example, let's just start with the basic first method. This is method 1. Whichever method you feel or is applicable for the question, try that, right? For example, if you have to compare 8 by 3 and 11 by 4, correct? You have to compare which ratio is greater, though you can calculate manually this, but I don't want to, do that. So what I'll do, I'll try to make the denominator same. I'll try to make the denominator same. So by making denominator same, what will happen, what I'm thinking is, if I multiply 8 by 3 with, let's say, some constant, let's say 1.66 or something, 1.66 something, alright, which will be around 313, or okay, say not 6, let's say multiply by 3. So 1.3, which will be around 4, and it will be around how much? 8, it will be around 10 point something, correct, right? So this you are getting, and you have 11 by 4. Now can you tell me which one is greater? This is greater. So the first method says that try to make denominator same, right? Try to make denominator same, correct? Make sense? Now method 2, for example, if I need to compare 12 by 17 and 15 by 19, let's say, right? This method is called as cross multiplier method. So what you do basically, you multiply this and you multiply this. Make sense? So what is it? 12 into 19, and you will be calculating 17 into 15. 12 into 19, and you will be calculating 7 into 15. So now you will calculate what is the value, whatever it's come, let's say 12 into 19, whatever the value is x, and whatever the value is y. I don't want to go for the calculation. If this x is bigger than the ratio 12 by 17, because you have calculated from first, right? 17, right? If this is bigger, the ratio 12 by 17 is the greater value. But if this is bigger, then 15 by 19 will be the greater value. Are you understanding or not? It's as simple as that. For example, let's do this one only. 8 by 3, 11 by 4. So 4 into 8, 11 into 3. What is 4 8s are 32, 11 3s are 33. Which is greater? 33 is greater, means 11 by 4 is greater. Are you understanding this? Are you understanding? Now you will be like, oh, this is the great trick I have. It's not the great trick again. That's why I'm saying, let's go with all the methods. Whatever is valid for the question, we'll take that and we'll proceed with it. So in method 1, what we have done, we are trying to make the denominator constant. Second method talks about the cross multiplier, where you cross multiply, and you check which ratio or the answer is greater. That particular ratio becomes the bigger, right? Now, for example, you are saying where it will fail, right? It won't fail anywhere. It just, when it making complex calculations, you have to shift it, right? You have to shift to the optimized method. Now, for example, let's say the question gives, tell me 3 7 4 3 upon 5 6, some random number, give 2 4 and 3 8 2 1 upon 5 7 8 3. Compare these two. Now if you do cross multiplication, you have to do 3 7 4 3 into 5 7 8 3, and you have to do 3 8 2 1 into 5 6 2 4. Though this is not a wrong way, But do you think this will consume much time, right? So again, this, now thinking about making the same same denominator, then also it won't work, because almost a denominator is same, kind of same, right? This is 5624, this is 5784, but here also there is a very minute change over here, right? So your approximation may go wrong over here. So that's why let's go to the method 3, called as percentage ratio. Percentage method. The first is denominator same, second is cross multiplier, the third is percentage. Now for example, let's say 173 upon 212, and let's say 181 upon 241, let's say. Okay, so if you have gone through my percentage videos and have attended the percentages class on the live sessions, you know how to calculate the percentage very well, right? So let me just give an example to you. In questions, I will be taking all the concept. That is how I go with. First we cover all the concepts, then we target the question, so that it's not like whenever the new question is coming, I'm introducing a new concept. No. Concepts has the limitations, whereas questions, the applying of those question in applying of those concept in question may vary, right? That's how it happens, right? But concepts remains the fixed. They are the standards, right? They are not given by me. They are in the books. They are coming forward to us, right? Somewhere we can manipulate in a strategy by applying those concepts. That's how we manipulate, right? That's how we invent tricks, right? Okay, so in the method 3, percentage, 173 divided by 212 and 818 divided by 241. Now you have to think, right? What is it, right? Now if you see the percentage concept, right, it is very very well known. If you see this 212, right, and 241, sorry, do you think it is like approximately what percent, like 21.2 and 21, so 10% will be 21.2, right? So it is approximately 2, 8, 16, 8, yeah, so it is approximately 80%, and this is approximately how much? Tell me. 241 is approximately how much? 80, 90? 80, like approximately. Correct. This is approximate 70s, nearly 70s, like 70 to 80, right? So you can write nearly 17, something like that, right? So see, 24.1 is what? 1%. 7, 2, 4, 7, 20, it's almost like that, right? Not 70, it may be 6. Okay, so you know now that it is more than 70 actually, but you consider in 70s line, and I'm considering this an 80s line, right? So you know which ratio is greater now. Are you understanding this? Any doubt here? Okay, so in method 4, now let's say same number 17, this is replicable if you can find 10%, because here you can see it is in 80s line, this is in 70s line, so there is a gap. What if both are in 80s line? Then what you will do? So let's say 173 divided by 212 and 181 divided by 225. So in that case, what you are going to do? You will see this also lies in 80 to 90%, and this also lies in 80 to 90%, right? So this is 10%. That's what we were calculating here. But here 10% does not give us the answer. Then we have to change from 10% to 1%. Now you check till what range it is going to come. Are you understanding? Till what range it is going to come. You go with the 1% estimation. Are you understanding? Are you understanding? No. Right? So it is coming 81 to 82%, if you see, almost. And it is coming 80 to 81%. So which one is greater? This one is greater. Are you understanding? So try to approximate in the 1%. If you are not able to approximate in 10%, that is almost you are not able to find it is 80, 70, 60. Then you comes to the 1% estimation, right? Right? Okay, the next method. Method 4. Percentage change calculation. Percentage change calculation. In this method, what happens is you need to find the percentage change. So see, ratio is what A is to B, right? If I say A is directly proportional to some X, it means that A is equals to Kx, where K is a positive number. You should remember this concept also. Very important concept. You will find some questions like this. But A is inversely proportional to Y means A is inversely proportional to Y. It means A equals to Ky. This is how we represent it. If someone is saying that A is directly proportional to B and A is inversely proportional to C, so this is how we represent them. This will come in proportion, but I'm adding it over here as well because the percentage calculation actually depends on this funda, this concept. So when someone is saying something is proportion to something, is proportional to something, direct or indirect, that we have to understand. So A is direct proportional means if A is increasing, B will also increase. How they will increase, that I don't know, so I'll consider as KB, where K is the constant which tells at what rate it will increase. Are you understanding? I'm saying that A will increase, I'm saying B will increase. But at what rate the both will be increasing will be defined by this constant K. Similarly, inversely proportional means if A is increasing, C will decrease. But if C is increasing, A will decrease. They are inversely proportional. If I am increasing, the person in front of me will decrease. If he is increasing, I will decrease. It will not be going in the same pitch, right? So by what constant? So it becomes K by C. So we'll get to know by what factor it is inversely proportional, right? So the percentage calculation, right? So here we calculate the numerator increase and denominator increase. For example, let's say what you have is 173 upon 212 and you had 181 upon 225. So let's say numerator percentage increase निकालते हैं. So what you will get 173 to 181 आपको मिलेगा. This 173 to 181 is I think approximately a change of this if you calculate it is approximately change of what 4 to 5%. If I find denominator increase, what you will find 212 say it is going to what 225. Can you tell me the percentage change in it? It is approximately 6 to 7. Now you see the denominator is changing from 6 to 7. That is the higher number. Means denominator is increasing at faster rate. Can I conclude this at faster rate? Therefore, can I write if denominator is increasing at faster rate means here if this is A, this is B is decreasing. So this is decreasing at faster rate, right? Sorry. If A by B, right? Denominator is decreasing, right? So this is was something and this is decreasing at the faster rate. Can I raise second? Right? So let's say if it is 2, it is coming 1. Sorry, is increasing. So this will type if it is 2, this is 4. I am understanding, sorry. So denominator is increasing, right? Sorry, it is increasing. So if it is increasing means if it is 2, it became like 4. So I told you, no, this concept, proportional. So denominator is the inversely kind of thing. So if this is increasing, the ratio will, complete thing will decrease. See, A by B, in A by B, if B decreases, the thing increases. A by B, if B increases, the whole thing decreases. That is what the concept of inversely proportional talks about us, right? Are you understanding this? This may be a little bit confusing over here because I just messed up here. Okay, let me just rephrase it. What is here? So what we are doing, we find the numerator percentage change. That how much is this increasing from what, and we find denominator percentage change, how it is increasing. Then we'll find which one is increasing. For example, if numerator is increasing, then what is means that here it was 2 and it is going to 4. Of course, this is the larger value. But if denominator is increasing, means here it was 2 and here it is 4. In denominator means the overall thing, this is the answer for that, this ratio. Are you getting it? Are you understanding it? Okay. There is one more way to do that. Should I tell that also, or you are confused here only? Let me finish it. Let's see what happens with that. Okay. And we'll see. Not an issue. Okay. For example, let's take this same example, 731,212 and 181 upon 225. The first step of this algorithm is put them in order such that both are in increasing order. So both are in increasing order in the sense you see 173, 212 and 818. So this, if I say 173, this is increasing, and 21 from this and this is increasing, and from this and this is increasing. So this is our increasing one. So 1733 upon 212 I'll put, and the second I'll put 181 upon 225. Understanding? Now this is called as first ratio and this is called as second ratio. Understanding it? Is this much okay to you? Now what we have to do is, you see this 173 is changing from 181. Can you tell me what is the difference here? 73, 7 plus 8, 8 difference. And 212 is changing from 225 plus 13, right? So ratio of change is what? Ratio of change is what? 8 by 13. Right? Now you compare the ratio of change with any first ratio and the second ratio. You compare the rate of change with the first ratio and the second ratio. For example, 173 upon 212 upon 8 by 13. Right? If ratio of increase or ratio of change is larger than the first ratio, then second is larger. So I'll just write the result. If ratio of change is larger than the first ratio, therefore second ratio is largest. Right? What if the same thing, ratio of change is equal, then both are equal, both ratios are equal. Third, if ratio of change is smaller than the first ratio, therefore second ratio is smaller. Understanding these three results, what you have to do is, you just have to calculate the change of the numerator, change of the denominator. Then you compare this value with this and this value with this. If this value is greater than this, then means second ratio is the bigger. If this value is lesser than this, means this is the bigger. So just note down all the results. So if ratio of change, that is what you have calculated, is greater than the first ratio, then second is larger. If ratio of change is smaller than the smaller ratio, then second is there. Understanding? Are you understanding this? Okay, now let's finish this off with the last concept or the topic, ratio and proportion, that is proportion. I want to solve questions as soon as possible because this theory will go on forever, right? But I have concised into 2 lectures. I won't take more than 2. So today I will be finishing the proportion, right? Then when we start the, questions, then I think you'll able to understand that what I mean to say here in the, in the concept. That is how you have to be patient. Otherwise, you can directly skip to the what do you call as to the question, and then you can do apply a question and we can discuss it, right? Okay, so what is proportion? We said that two ratio are equal, right? Okay, let's say a comma b comma c comma d are said to be in proportion only if a by b equal to c by d, or we depend like this: a by b is proportion to c by d, means the way a by b is related, the same way c and d is related. This is also a way of saying that in the way a is related to b, in the same way c is related to d, and mathematically we express this as a by b equal to c by d, where a and d are called as extremes and c comma b is called as means. So if two ratios are equal, that is if two ratios are equal, four quantities composing them is said to be proportional, that is a is to b proportional to c is to d. Understanding? Now what is continued proportion? There is something called as continued proportion. So continued proportion is nothing but a is to b is to b is to c. That is these two are common. That is called as continued. Means the way a is related to b, then the same thing is related to c. So here the a and b are the different things and c and d are the different things. Here the way a is related to b, the same b is related to c in some way. So that is a by b equal to b by c. So ac equals to b square is equals to v square. Are you understanding? Now if three quantities are proportional, so three quantities are proportional means a is to b is to b is to c. If three quantities are proportional, correct, then we can also write in this way. If you want to write, if three quantities are proportional, you can write this result directly, that a is c is equal to a square and b square. Same way, correct? It just see, simple way. Anyways, you know ac equals to bc square, right? From there also, if you want to drive, otherwise you leave this result. Okay, it may create a problem to you. Now I want to just show you some of the terms. Let's do that and let's finish this. Okay, I just want to jump into the question, then only you will be understanding what we have done so far, right? So we have something called as mean proportion. So mean proportion is nothing but, can anyone tell what is mean proportion? So mean proportion of two numbers will be under root of AB. See, this will be understanding in arithmetics also. Okay, but that I told you. So the concepts are always interrelated. Whatever you are studying in here, you may be studying in averages, you may be studying in percentage, or you may be studying in time and work. So many things are there, right? So these are interrelated, right? Now next term you will find is invertendo. Invertendo. So what is invertendo means? It means if a by b is equals to c by d, then invertendo means you invert it, that b by a is also equals to d by c. You just invert this, they will get it. This is called as invertendo. Okay, just telling you the names so that you can see. Then we have alternando. So by the word alternando, can you find out what does it means. It means if A by B is equals to C by D, in that case, if you alter them, that is, you put this and this, that is, then A by C is equals to B by D. This is called as alternando. Now what is componendo? Componendo is if A by B is equals to C by D, then A plus B upon B, C plus D upon D. You just multiply with the denominator. You just add the denominator. That is called as componendo. Similarly, can anyone tell me dividendo? What will be having in dividendo? In dividendo, if A by B equal to C by D, then A minus B upon B becomes equal to C minus D upon D. Just you subtract it here, you add it out. Now, combination of both these, componendo and dividendo. Can you guess now? Componendo, dividendo. First, componendo, dividendo, what is it? If you have A equal to B equal to C by D, so component dividendo will be what? A plus B upon A minus B equal to C plus D upon C minus D. So by this, we are done with the theory. I was going a little, faster. The reason is I just wanted to finish theory in the second this unit. I don't want to carry it, right? But this is all concept what we have seen, right? Now I will give you a Brahmastra. Please listen it very carefully, right? Ration, because we'll start with the questions, right? So there are 3 important tips from my side on this ration proportion. The first tip is assumption. When you are assuming anything, right? When you are assuming anything, you should validate. Validate in the sense, assumption को validate करना important है, क्योंकि कई बार आप assume करते करते ही पूरा क्वेश्चन सॉल्व कर देते हो, बट व्हेन इट कम्स द वैलिडेशन पार्ट, जब हम उसको वेरीफाई कर रहे होते हैं, डजंट मेक सेंस, राइट? आई विल गिव अ दिस क्वेश्चन, okay, and most of you will do the same thing. You will assume and you will get the answer as an assumption only. But when you are going to put that value back to the solution or the question, you won't be getting the same equations, right? कहने का मतलब आपको assumption करना है, लेकिन assumption ऐसे नहीं कि कुछ भी कर दिया. You should get a proper validation. For example, 4:2 is there. So consider as 4x and 2x. Consider as 4x and 2x. Now if you assume x is 1, then it becomes 4:2. When x is 1, correct? ये आपका assumption है कि x equals to 1, तब validate करेंगे आप 4 and 2 is the value. But similarly, writing just 4, 2 as a value doesn't make sense. Or, for example, the complete thing, if you have to assumption that complete thing was 100, now 4:2 is what? 4:2 is what? 4:2 is nothing but 2:1 kind of thing, right? So means if you divide 100, so this 2 will get what? 2 multiply by, what is it? 100 by 3. If I am not wrong. And this will get what? 1 multiplied by 100 by 3. So this is assumption that 100 is there. From this you are getting one of the coordinate. Again, this can be 1000, this can be 10,000. So ये तो आपका 100 का assumption है, तो आप जो भी आगे कैलकुलेशन कर रहे होगे वो आप 100 लेकर ही कैलकुलेशन कर रहे होगे, करेक्ट? सो assumption को वैलिडेट और वेरीफाई करना इंपॉर्टेंट है. सेकेंड इंपॉर्टेंट, राइट? सो सेकेंड इंपॉर्टेंट मैंने आपको बताया अभी इसमें प्रोपोर्शन में भी कि डायरेक्टली प्रोपोर्शनल मीन्स व्हाट, कि A is directly proportional to B means is nothing but KB, and A is directly inversely proportional to C means A equals to KC. If I write A is directly proportional to B and inversely proportional to C, then same equation you can write A is B upon C, A equals to KB by C. So something like this you will see. The third Brahmastra, options. In ratio and proportion, the best part is option. If you pick one option as an answer and you try to put that in the ratio, and the ratio satisfies, and ratio satisfies, and ratio satisfies, therefore your answer, your problem is done. Assuming. And fourth, if equatic question means you have questions of equations a minus b, b minus c, d minus something something, all those equation, p square minus q square, p plus q something something, all those questions, equatic questions, try to find or try to put basic values. Now what is basic values? Sorry. Now what is basic values? Can anyone of you tell me? So I told you basic values are nothing but like basic values. So basic values are 0, 1, 2 and 3 like this, right? So this is what. So try to put them into the solution and try to get the answer. They will be using all these four concepts: first, second, third, fourth. That is assumption, the equatic question, basic values you're going to put from the option, you're going to see, and inverse proportion. So by this we are done with the theory of ratio and proportion. In the next video or the next sessions, we are going to talk about the questions. So we'll be solving all the question banks of the DPP. So that is, I think, how many 350 questions are there. So 150 will solve in the first set, right? Okay, so guys, here I have to stop. I already went ahead of time, but I just wanted to take this theory sessions, 2 theory sessions, and followed by the questions. With questions only, I think you will get a practical idea, but it's okay. So the people who are on the live classes and the applications, try to solve beforehand. So, and those who are getting on the other platforms, YouTube and other things, please do like, subscribe and share it, and hope you are also getting this, right? So thank you everyone. Let's meet in the another session where we'll be solving the questions. Till then, take care.